Hello students, today we'll see grade 9 physics unit 5, that's about simple motions. And don't forget to subscribe the channel, like and share the videos. And if you have questions related to the previous topic as well as related to this simple motion and comments, write us on comment. Okay, hello students, my name is Roskiza and I'm your physics teacher. Today we'll see about grade 9 physics, that is simple motion. And this unit is unit 5 of grade 9. Therefore, when we say simple motion, mechanism that multiply or manipulate what magnitude, force and displacement is simple motion. We have 6 simple motions. The first one is lever, and the second one is wheel and axle, and the third one is what? Pulley. When we say lever is used to separate or to split a single thing, and wheel and axle is used to rotate a material. Therefore, wheel and axle, from the name it has what? Wheel and axle. Also, pulley is a rope and a rolling wheel which it have. Therefore, we will see each one by one. And the other three is inclined plane, which is the inclination as you see from this. And the third one is wedge. Wedge is used to separate what? A material. And the sixth one is screw. Screw, as you saw, screw is the simple motion which we use to lift cars and some other materials and to attach two or more objects together. And for this all, we have a mechanical advantage. The ratio of the magnitude of the resistance to effort is mechanical advantage. Therefore, mechanical advantage is equivalent to the ratio of the magnitude of resistance. When we say resistance, in other words, it is named as load. Therefore, load over effort is the mechanical advantage. And in symbol, mechanical advantage is equivalent to L over E. And this ratio of distance traveled by the effort and distance traveled by the force is also another ratio for the mechanical advantage. A calculated ratio allows to designers to manipulate what? Speed, distance, force, and the function of the graph, the function of the motion. Therefore, the other thing is, as you see, let us take mechanical advantage example. Mechanical advantage of 4 ratio 1. That means mechanical advantage, which is equivalent to 4, tells us what about a mechanism. For example, magnitude of the force is this mechanical advantage of force ratio 1 or mechanical advantage of force indicate that the applied or the effort is multiplied by what? 4 times, increased by 4 times, or the load is greater than the effort 4 times, or the effort is less than the load 4 times, indicate that the mechanical advantage. Therefore, when we say mechanical advantage of 4, it indicates that the effort is greater than the load. No, the load is greater than the force 4 times. Therefore, how much the force is multiplied is calculated by using this mechanical advantage. Therefore, mechanical advantage of 4 indicate that the effort is multiplied 4 times. Okay. Distance traveled by the force. Effort, when we say mechanical advantage of 4, in other words, effort force travels 4 times greater than what? The resistance force or the load. And the other thing is work, the force applied on an object times the distance traveled, as you know, and by the object parallel to the force. This is the initial point. We apply a force on this object, and initially at this point, and the force applied moves to this final point. Therefore, from this up to this, it is what? The distance and the applied force. From this, the work done is equal to what? Force times distance, parallel distance. And as you see, it is pushed from this point, and when you push by applying a force, the object moves from this point to this point. Therefore, there is a distance and there is a force. By using these two, you can calculate the force. And work for the product of effort times distance. Traveled with the same regardless of what? The system of mechanism of advantage. As you see, this object is pushed from this point up to this point, but it is moving from this up to this. Therefore, by this applied force, let us say this distance is S. This distance is S from this up to this point. The distance is S. From this up to this, it is what? H. And the load is the object's weight, that is mg, and the effort is the applied force F, and this applied force F is mg sine theta for an inclined plane. Therefore, the mechanical advantage is equivalent to mg over what? Mg sine theta. If there is no friction, mg is cancelled by mg, mechanical advantage becomes what? 1 over sine theta. And if you are asked to calculate work in, let us write at this point, work in, that means the input work done, is equivalent to effort times what? Distance moved by the effort. Distance moved by the effort is from this up to this point. Work out is equivalent to what? Load times what? Distance moved by the load. Distance moved by the load is from this up to this, that is h. Therefore, L times H, L times H we use. Therefore, this is work in and work out. Mechanical advantage ratio, 1 is the magic number. 1 is the magic number. That means if you got 1, the machine is 100% efficient. If the mechanical advantage is greater than 1, we are saying that the proportional less effort force is required. That means the mechanical advantage is less than 1. This indicate that the object is what? A speed multiplier. It can't multiply a force. That means distance moved by the effort is greater than distance moved by the load is greater than distance moved by the effort. And the second one is if the mechanical advantage is less than, this one is greater than 1. Therefore, this expression is for less than. But for the first, if the mechanical advantage is greater than 1, this indicates that what? It's a force multiplier. It multiplies a force. That means the effort is multiplied by an integer number greater than 1. Or the force is increased, or by applying a small force, we can lift large amount of load. But in the second case, that means if the mechanical advantage is less than 1, by applying large amount of force, we lift what? A small object, but at this time, we move the object in large distance. Distance moved by the load is greater than distance moved by the effort. But if the mechanical advantage is equivalent to 1, the material cannot multiply a force as well as what? A speed. Therefore, mechanical advantage can never be less than or equal to 0. Okay, ideal mechanical advantage. When we say ideal, that means it's not in actual case, it's not gotten in actual case. Therefore, theory-based calculations, friction loss is not taken into consideration. Ratio of distance traveled by effort and resistance, and using the efficiency and safety factor design calculation gives us the ideal mechanical advantage is equal to distance traveled by the force times divided by distance moved by the resistance, and this one is sometimes expressed as velocity ratio. Velocity ratio and mechanical advantage is equivalent if there is no friction or if there is no loss of energy. And actual mechanical advantage is the mechanical advantage of an object if there is what? A frictional force. But ideal mechanical advantage is a mechanical advantage if there is not what? Consider the ratio of distance. That means if there is no friction loss. But in the actual, there is what? Losses of friction. There is an energy loss because of friction. And this actual mechanical advantage is equivalent to load over what? Effort. And real world mechanical advantage. Can you think of mechanical advantage that has a mechanical advantage greater than 1? Yeah. It's true. It's true. There is a mechanical advantage which is greater than 1. For example, you can take a wind power plant. And can you think of a mechanical advantage that has less than 1? We don't think. Sometimes there is a mechanical advantage which is less than 1, but most of the time the mechanical advantage of some machines is greater than 1. And let us see lever. When we see levers, lever is a rigid bar, as you see, a rigid bar used to exert pressure or sustain a weight at a point of its length by the application of what? Force at a second and turning at the third on the fulcrum. Therefore, we have three types of levers: the first class, second class, and third class lever. This first, second, and third is dependent on the position of the fulcrum, the load, and the effort. Therefore, first, let us see for the first class. In the first class, the fulcrum is at the middle. In the second class, the load is at the middle, and in the effort is at the middle is the third class lever. And this one is the load, and this one is what? The effort, and this one is the load, and this one is the effort, and this one is load, this one is what? Effort. Therefore, as you see, between the effort and the load there is what? A fulcrum. Therefore, this one is what? First class lever. And here at the middle there is what? A load. Therefore, this one is second class lever. And here at the middle we have an effort. Therefore, this one is what? Third class lever. Therefore, if the effort is at the middle, third class. If the load is at the middle, second class. If the fulcrum is at the middle, it's what? First class lever. Let us see first class levers first. Fulcrum is located between the effort and the resistance. As we said, the first class levers are levers. At the middle they have what? A fulcrum. Therefore, this one is the first class lever. For this, if the effort distance and the load distance is equivalent, we have a mechanical advantage of what? 1 at this point. Therefore, if these two distances are equivalent, the mechanical advantage is 1. That means it doesn't multiply a force as well as what? A distance. And effort and resistance force are applied. The lever arm are the same direction. For example, for the second, if this fulcrum is nearest to the effort, the distance of load and distance of effort, when you compare, distance of load is greater than distance of effort. At this time, the mechanical advantage is what? Less than 1. Therefore, it's what? Speed multiply. It multiplies what? Speed. And if the fulcrum is nearest to the load, distance moved by the load is from this up to this, and distance moved by the effort is from this up to this. Therefore, which one is greater? Distance moved by the effort is greater. Therefore, the mechanical advantage is greater than 1. At this time, it becomes what? Force multiplier. Therefore, first class lever, it may be a speed multiplier, it may be force multiplier, it may be what? Direction changer. It depends on the position of the fulcrum. If the fulcrum is at the center of the two, load and effort, it is what? Direction changer. That means the mechanical advantage is 1. If it is nearest to the effort, if it is nearest to the effort, it's what? Speed multiplier, because the mechanical advantage is what? Less than 1. And if it is nearest to the resistance or the load, it's what? Force multiplier, because the mechanical advantage is what? Greater than 1. Let us see second class lever. When we see second class lever, fulcrum is located what? At the edge, and at the middle we have what? The load. At this point, as you see, the fulcrum is at the edge and the load is at the middle, and the effort is what? At the edge. And the resistance force effort is opposite direction. Therefore, as you see, from this up to this one is distance moved by the load. From this up to this, it's what? Distance moved by the effort. And for this reason, always the mechanical advantage is greater than what? 1. Since the mechanical advantage is greater than 1, second class lever is what? Force multiplier. Always second class levers are force multipliers. And when we see third class levers, fulcrum is located at one end of the lever, but at this time, unlike to the second, at the middle we have what? Effort. And from this up to this one is distance moved by the effort. From this up to this, it's what? Distance moved by the load. Therefore, as you see, distance moved by the load is greater than distance moved by the effort. Therefore, the mechanical advantage is less than what? 1. For this reason, third class lever is always what is what? Speed multipliers. And to calculate the velocity ratio, as we said, we use what? Distance moved by the effort over distance moved by the load. You do not forget this equation. If you are asked to determine the velocity ratio or ideal mechanical advantage, we use what? Distance moved by the effort divided by distance moved by the load. The other thing is moment or torque. Sometimes it's named as torque. And moment or torque is a turning effect of a force about a point equal to what? The magnitude of the force times the perpendicular distance from the point to the line of the action. Therefore, moment, it's symbolized by a Greek letter tau, or sometimes we use capital letter M. Distance times force. And this distance is a perpendicular distance. Therefore, torque is a force that produces or tends to rotate an object. If this force is greater than this one, this object turns to this direction. And if this force is greater than this, if this torque is greater than this one, this object turns to this direction. And this turning effect is named as torque. And this torque is calculated by using R perpendicular times what? The force F. And R perpendicular means from this up to this distance, and the force F, which is applied on the object. And lever moment calculation. We have one example here. We have an effort. The effort is 50 lb, and the distance from the effort to the fulcrum is 5.5 inch. And calculate the effort moment acting on the lever above. Therefore, if you are asked to calculate the effort, we use what? Moment is equal to what? Distance times force, and the distance is how much? 5.5 times what? 50, the force. And finally, you get how much? Which is equivalent to 82.5 inch lb. Or if this one is in meter and this one is in Newton, your final answer becomes what? Newton meter unit for moment or torque. Therefore, the SI unit is Newton meter. And lever moment calculation. When the effort and resistance moments are equal, the lever is static. The lever is in static equilibrium. If the moment or the torque on effort and resistance are what? Equal. That means torque of effort is equal to torque of what? Load is equivalent. We can say the object is what? In static equilibrium. When we say static equilibrium, a condition where there are no net external force acting upon a particle or a rigid body, and the body remains what? At rest, or continues at constant velocity. It may be in motion, but the velocity is constant, or it may be at rest. And the other thing is, on this last time we have seen the moment for 50 lb and 5.5 inch, and here also we have 36.5 lb resistance. What will be the distance? Using what you know regarding static equilibrium, calculate the unknown distance. Therefore, since this torque 1 is equal to torque 2, and this one is d1 f1 is equal to what? d2 f2. And from this, if you are asked d2 is equal to what? d1 f1 over what? f2. You can apply this. As you see, static equilibrium is equal to moment of effort is equal to moment of resistance, and moment of effort is equal to, which we calculate before, that is 82.5 inch lb, and for the resistance, this one is the distance d, and this one is what? The force. No, this one is the force, and we are asked to determine the distance. Therefore, for distance is equal to 32.5 inch LB divided by 36.66 LB, and finally you got how much? 2.25 inch of distance if they are in static equilibrium. And ideal mechanical advantage, both effort and resistance for wheel traverse in a circle. If I'm post, circumference is the distance around a perimeter of a circle. Therefore, circumference is equal to 2 pi r. And since it is circumference, we can use 2 pi times r. And for this, 2 pi is the effort arm, distance moved by the effort, and 2 pi for the resistance is what? Resistance of the r. Therefore, we can take small r and capital R for both. And finally, the ideal mechanical advantage is equivalent to 2 pi over effort arm length divided by 2 pi times resistance arm length. Or if we take this distance is small r, and this distance from this up to this, it is capital R. And finally, 2 pi or effort arm is capital R. Therefore, 2 pi times capital R over what? 2 pi times small r. Finally, this cancel out, and capital R over small r is the equation which we use to calculate what? The effort R. And lever actual mechanical advantage is the ratio of applied resistance to the applied force. Therefore, force over load over, this one is load, and this one is what? Effort. Load over effort. The load is what? Here the load is 32 and the effort is what? 60. 32 over 60. 32 LB over 60. LB is cancelled by LB, and by 60 it becomes what? 2. Finally, you can get 2 ratio 1, or finally the mechanical advantage is 2. And what is the ideal mechanical advantage of the lever? To do this, we use what? Mechanical advantage, ideal mechanical advantage, or velocity ratio. In other words, ideal mechanical advantage is equal to velocity ratio. It is distance moved by the effort over distance moved by the load. And distance moved by the effort is from this up to this, that is 5.5 divided by from this up to this 2.25. Both are inch, and this one is also inch. Inch is cancelled by inch, and 5.5 over 2.25 gives us how much? 2. Therefore, dE over dr, that is 5.5 over 2.25. Finally, you get what? 5.5 to do this, it is 2.44 is the final answer. As you see, the mechanical advantage and the velocity ratio both are greater than 1, and both does not have what? A unit, because since they are what? Ratio. Since they are the ratio. Why the ideal mechanical advantage is larger than the actual mechanical advantage? This is because since it is an ideal, we don't consider what? The frictional force, or we are considering that if there is, in the absence of frictional force, it is what? Ideal, but actual is with a frictional force. Therefore, the mechanical advantage of actual is less than the ideal. And the other thing is efficiency. Efficiency is in a machine the ratio of useful energy out, or efficiency have so many equations. This one is the efficiency in terms of what? Actual mechanical advantage and ideal mechanical advantage, or velocity ratio is also used in this in the place of ideal mechanical advantage. We can also calculate efficiency. Efficiency is equal to work out over what? Work in times 100% is also another equation, and efficiency is equal to power out over what? Power in times 100% is also another equation. Therefore, you can use one of the three depending on the given. What is the efficiency of lever? On the previous slide, click return to the previous slide, and for the previous slide we have what? We have here the ideal mechanical advantage 2.44, and the mechanical advantage actual it is what? 2. Therefore, let us substitute that. The actual mechanical advantage is 2, the ideal mechanical advantage is 2.44. Therefore, the efficiency becomes 2 over 2.44 times 100, and finally you get how much? 82%. This indicates that from the total energy given to the machine, 82% is used to do a mechanical work. a mechanical work. The rest 80% is what? Wasted. No machine is 100% efficient because always there is what? Loss of energy. Therefore, from this, as you see, since it is 82%, the rest 80% is what? Lost. The other thing is wheel and axle. Wheel is a lever arm that is fixed to a shaft, which is called an axle. As you see, this one is the axle, and this one is what? The wheel. And the wheel and the axle moves together as a simple lever to lift or to move an item by rolling. And it's important to know that within the wheel and axle system, which is applying the effort and the resistance force, the wheel or the axle. When we see, can you think of an example of wheel driving an axle? And when we see wheel driving an axle, this one is also a wheel and axle, this and this, and there are so many examples. Wheel and axle ideal mechanical advantage is distance moved by the effort over distance moved by the the resistance or the load, and this one is velocity ratio or ideal mechanical advantage. To do this, we use what? Circumference of the tire or the larger divided by circumference of the smaller. That means this gives us dE is equivalent to diameter of the effort. That means wheel or axle, it depends on the situation. Therefore, pi times diameter of the axle or the wheel, which we are exerting a force. Therefore, here, as you see, this one is the effort and this one is what? The load. Therefore, the effort is exerted on the tire. Therefore, distance from this up to this is, or the diameter of the tire gives us what? The distance moved by the effort, and the diameter of the axle gives us for the distance moved by the load. Therefore, ideal mechanical advantage, these two are cancelled out, and finally it's what? Effort diameter over resistance diameter. Therefore, velocity ratio is equal to diameter of effort over what? Diameter of load. What is the ideal mechanical advantage wheel and axle given in the above? Let us see that. Since this up to this is how much? 0.6, and this distance is 0. No, the above one is the load is 0.6. No, 6 inch is the diameter of the tire, and the diameter of the tire is from this up to this is 20. Therefore, 6 over 20. Finally, you got how much? 0.3. 0.3 is the ideal mechanical advantage. What is the ideal mechanical advantage for the above wheel and axle? Finally, what is the ideal mechanical advantage? In the first, the axle is driving. That means the effort is act on the axle. For the second, if the effort is acted on the wheel, 20 over 6, that is 3.33 the answer. Therefore, it depends on the effort which is acting either in the wheel or on the axle. You must take care on that. Wheel and axle actual mechanical advantage. Actual mechanical advantage is what? Load over effort. Therefore, you can use load divided by effort. For example, here, what is the actual mechanical advantage? If the wheel is driving, that means if the force acting on the wheel is the effort and the wheel is this one, therefore this one is effort in this equation, and this one is what? Load. Therefore, we can use 200 lb load over effort divided by 70, you can get 2.86. But what if this one is the load and this one is the effort? It's what? Vice versa, 70 over 200 becomes. Therefore, the efficiency of the wheel and axle assembled for this, as you say, the actual mechanical advantage is calculated already, and the ideal mechanical advantage for what? Wheel driving. The wheel is the driving one, therefore 20 over 6, it's what? 3.33. You can substitute the velocity ratio as 3.33, and the actual mechanical advantage is 2.86. Therefore, 2.86 divided by 3.33 times 100%. Finally, you can get how much? 85.9%. 89. The rest is lost. The rest is lost. The other thing is pulley. A pulley is a lever consisting of wheel with a groove in its rim, which is used to change what? The direction of the magnitude of a force exerted by a rope or a cable. A rope or cable. And pulley, ideal mechanical advantage. Fixed pulley, we have two types of pulley, fixed and movable pulley. For fixed pulley, it's what? First class lever, which is ideal mechanical advantage is what? 1, and only changes what? Direction of the force. But movable pulley, this one is the movable and this one is fixed. This one is the fixed pulley and this one is what? The movable pulley. And in movable pulley, it is second class lever, and the mechanical advantage, the ideal mechanical advantage is how much? 2. And it changes force direction stays constant, but here it's what? Since the mechanical advantage is 2, it makes what? It makes a force multiplier. Therefore, movable pulley is force multiplier pulley, and fixed pulley is a direction changer pulley. Pulley is combination. Pulley is combined in so many manners, and this combination is called as compound pulley. As you see, for this combination of pulley, we have how many pulleys? 1, 2, 3, 4 pulleys. Therefore, for this, if you are asked to calculate the mechanical advantage, you must simply count the ropes, neglecting the force applied rope. This one is the force applied rope or the effort applying rope, and the rest are 1, 2, 3, 4. Therefore, the mechanical advantage is how much? 4 for this rope. Therefore, we count the mechanical advantage, the rope. By counting the rope, you can get the mechanical advantage. And compound machines. When we say compound machines, one simple machine is used after another. That means by combining 2 or more simple machines, we can get a compound machine. And the ideal mechanical advantage, for example, here we have one compound machine, pulley plus what? Lever. And we have also another compound machines, which are compound combination of pulley. This one is compound combination of pulley. For such compound of combination of pulley, the pallet ropes and cables out of one pulley can become what? The input for another. Therefore, this is what? A compound machine. And since there are 3, the total ideal mechanical advantage, the product of the ideal mechanical advantage of each for any compound pulley. For the first, it's what? 2. And for the second also what? 2. For the third also 2. Finally, we can get what? The mechanical advantage of this compound pulley is what? 8. Pulley actual mechanical advantage is load over effort. The load is at this point, and the effort which is applied is this much. Therefore, 800 divided by 230 is used. 800 divided to 230, and finally you can get how much? 3.48 is the actual mechanical advantage. What is the difference of the pulley? To get this, 1, 2, 3, 4. The mechanical advantage is this much, and the ideal mechanical advantage or the velocity ratio is how much? 4. Therefore, 3.48 divided by 4 multiplied by what? 100% is the efficiency. Let us do that. Efficiency is equal to actual mechanical advantage or ideal mechanical advantage or velocity ratio. 3.48 divided by 4 times 100%. Finally, you got how much? 87%. 87% is the mechanical advantage. Common misconception: angle does not matter. Either in different angle or not, the mechanical advantage of the pulley is what? Not similar. Here, the ideal mechanical advantage is 2 for this, but for this, you must use what? Trigonometric identity. The other thing is common conception of count the effort strand if it's pulley up. Sometimes it's true, but it's not always. Pulley ideal mechanical advantage is equivalent to strand opposing the load. Therefore, for this, the mechanical advantage is 2. This is all about simple machine. Until next time, have a nice time.